one, we're going to go through this point that they highlighted and then just, use the slopes as your instructions. So you're going to do kind of something like that, and there's a horizontal asymptote. So does yours look vaguely like this? Yeah, and you have to go all the way to the edges. Now, it's only worth 1 point. I'll share and show you the scoring guideline. It just looks like that. I'd love to believe they would just give it to you. I mean, it says on here, extend reasonably close to the left and right edges. No obvious conflict. So as long as you have no obvious conflict, I feel like you should get it. Okay. Yep. What happened? Okay. Letter B, I'm going to fit this in right here. If I write small enough, I might be able to get it to work here. All right, it says use the tangent line equation. What two things do you need to write an equation? A point and a slope. Now, they give you the points, don't they? It's 0, 5? 0, 5. Now, this is weird to write m equals for the slope because the variables in this, it is m. I guess I should have read this scenario to you to start out with. Milk is taken out of the refrigerator and placed in a pan of hot water to be warm, presumably for a baby. Okay. So the temperature of the milk is going up. Can you see that here? Temperature of the milk going up? Okay, cool. In degrees Celsius, so this is a European baby. All right, and then this is your dm dt. All right, so again, it's weird that I'm writing m for slope and the equation is m, but it was m for milk. All right, slope comes from derivative. This dm dt is your derivative. Now, weirdly, often you plug in the t value or the x value, whatever you want to call it. In this case, we're going to plug in m. M is the 5. This is t and this is m if you want to label them. So if you plug 5 in for m, for milk, 40 minus 5, so 35 fourths. Now, if you use x and y, they're going to give it to you. I would try to use the variables in the problem, though. It's going to be m minus what? 0. 5 equals 35 fourths, parentheses, t minus 0. And then we want to do an approximation for at what time. Now, I would argue that we shouldn't really be able to do an approximation at 2 minutes. This is my personal opinion, because where did we write the equation line? 0 minutes. I think 2 is not actually that close to 0. Do you know what I'm saying? It should be like 0 point something, but alas, I didn't write this problem. All right, so we're going to say the milk is approximately 35 fourths times 2 minus 0, and then what? Plus 5. It would be degrees Celsius, but did they ask you for that? No, so don't bother, okay? I'm going to share my screen and we'll read scoring guideline. Is a point for getting the 35 fourths, then a point for your final answer. Cool? Only 2 for that. We didn't really do that much. Okay. Part C, I'm going to fit in right here as well. We write small enough, we'll be able to make it fit. Now, double derivative, this is prime, all right? So d squared m dt squared equals. Here's my personal preference, and I hope you'll agree with me on this. I like to, because they do this often, they'll give you something with a coefficient out front and then parentheses. I like to distribute this first and then do the derivative. I like to do the algebra first and then the calculus. So if you distribute through here, that's going to give you 10 minus 1/4 m. I just find it a lot easier to then do the derivative based on that rather than something that has parentheses in it. That's my 2 cents. I see some heads nodding this. I think you'll come with me on that. So derivative of this. Derivative of 10 is 0. That's gone, which is kind of why I do that. Now, derivative of negative 1/4 m is negative 1/4 dm dt. And this is going to feel really redundant in a second because that's negative 1/4 times what? What is dm dt? Well, it's that. 10 minus 1/4 m. I feel like I've seen them do this several times where you basically just write the same thing over again. And I think they do it to intentionally confuse people because if I wasn't sitting here explaining this to you, wouldn't you be like, hey, didn't I just write the same answer that it already was? Like, yeah, and it feels like that's what you did, but that's the answer. I'm pretty sure it's a point for that. All right, now they want more though. So what else are they asking for? Go ahead and read through the rest of it. We want to use that to do what? Whether what we just did in part A was over or under. Now, why'd they ask you for a second derivative? What does a second derivative tell you about? Good. Okay, so like here's the two choices. And you don't have to write this, just look it. Concave down would be this way. If you have a tangent line, that means the tangent line is over. Do you see how that would be over? Okay. Or you can have concave up, which would look like this, and your tangent line would be under. I don't necessarily memorize that. I just draw myself a picture and I know what up and down is. Do you know what I'm saying? Like trying to brag or anything, but I would just draw a picture. I don't try to, I'm a bad memorizer. But I know what up and down are. So I would just draw that. Okay. So these are the two options. So we want to find our second derivative at m equals 5. Why would I want to find that such that m is 5? Why 5? That's where it was, right? That's the point of tangency that we're talking about, was when m is 5. All right, so if we plug 5 into this thing, we're going to have negative a fourth times 10 minus, sorry, I didn't write that very well. Let me try and fix that. And if I plug in 5 for that, that would be 5/4. Now, this is non-calculator, and you don't need to figure out what that actually is. You just need to know whether it's positive or negative. So what do you think? Is that value positive or negative? That would be negative. 10 minus 5/4 would be something positive, and then you multiply it by negative 1/4. Okay, so which one of these choice A or choice B have we got here? Choice A, concave down. So we're going to say overestimate. Good job. Because second derivative at m being 5 is negative, so m is concave down there. When you're writing a justification, the because, usually you know what the answer is. When you say because, you're just explaining why you picked that answer. That's why I usually say you're right, and I'll say why you did it. Now there's some symbols in there with the such that bar and all of it looks sort of complicated, but we're just saying at that point where m is, the milk is 5, negative. So that means concave down, and that means overestimate. Go ahead. If you prefer words than symbols, if you're more a verbal person than a symbols person, yes, you can write second derivative at m equals 5. Like if you like the words better, absolutely. So let's look at the scoring guideline for that one. It was worth 2 points. So you get 1 point for the second derivative. So even if you couldn't write the sentence, if you held your wits about you, you'd get a point for getting that second derivative, and then it's a point for the sentence. All right, here it comes. What does this say to do? There it is. Okay, let's go over the steps. Separate, integrate, plus C, initial condition, get y by itself. In this case, it's going to be m, okay? So how would we separate these? How do you move over the 40 minus m? It has to stay together because it's in parentheses. Perfect. 1 over 40 minus m dm equals 1/4 dt. You would get a point for that. So even if you lost your mind afterwards, you should be able to separate it, okay? It is going to be ln, but hold on a second because there's a little bit of a trick to it. I don't make you write out when it's a u substitution because it's a real simple thing. But, and just watch, I don't want you to write it out. I'm just going to explain why this happens here. If you let u equal 40 minus m, what is the derivative of that? The 40 would go away. It would be negative 1 dm. So all I want you to do is throw a negative in front of your ln. It's kind of like if there was a 7 there, you would put a 1/7 as an adjustment. Do you remember us talking about that? It just has a negative. Now, if it had been m minus 40, would we need to do that? No, you would just proceed as normal, but they put it the other way around, so you need a negative. And negatives are hard. They're evil. They're trying to trip you up. All right, how about this side? Antiderivative of 1/4 dt. 1/4 t, good, and then plus a constant. We're going to plug in 0 for time and 5 for m. So if 0 is time, like that's all gone, which is nice. If you plug in 5 for m, on this side, you're going to have negative ln 35. So we're going to recopy that previous step exactly like it looks, but we're going to put minus ln 35 in place of the c. I hope you're writing with pencil. I'm going to just erase and adjust a couple of things with these negatives so I don't have to keep recopying the whole thing. The more times you recopy, the more likely it is you're going to do a copy error, all right? If I divide by a negative, everything's just going to flip-flop its sign, right? So that would make this a negative 1/4 t and a plus ln 35. You see how I did that? I just erased. If you're writing with pen, you can scribble it out. All right, then what? E both sides, exponentiate. If you want to cancel out the e and the ln and bring the 35 out front, you can. And I think the last time I did one of these, that's how I did it. But you're within your rights to just do that. And it's safer because you're not doing anything. But if you wanted to get fancy and write 35 e to the negative 1/4 t, you could do that. All right, I'm going to erase this 40. How do I bring that to the other side? Yeah, subtract 40. And then I'm going to erase this negative and do the same thing. Everything's just going to flip-flop its sign. So it's going to be minus e to the blah, 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 plus 40.
So you don't switch the sign of
The exponent is not going to change. Okay, I remember what this one is. It's a point for separating it. It's a point for this step where you do the antiderivatives. It's a point for getting the negative ln 35, and then it's a point for the final answer. So it's 4. That one was really hard, in my opinion. You had to divide by a negative, not once, but twice. And negatives are hard to begin with, and they made you do it twice. Plus, there was an ln and an e, so it was tough, in my opinion. I think that one was hard. So what are you given for this one?
the interval.
F prime. There we go. You're given the derivative. All right. Define on a closed interval negative 2 to 8. This is important. What do we call this?
Critical point.
Nope.
The
Initial condition. Good job. That's going to come up at some point. An initial condition is never extra. You know how sometimes they give you more information than you need? An initial condition will never be that. If you did this whole problem and you didn't use this, you had a whoopsie somewhere, okay? 2 line segments and a semicircle. All right, does F have F, which is not the graph you're looking at? Why on earth would they ask you questions about the graph you have, okay? Does F, which is not this graph, have a relative minimum, maximum, or neither at 6? What did you guys think? Neither. Okay, so we're going to start our sentence. F of X has neither, except I can't spell. Oh my gosh, I can't write. I can't spell or write. Hold on a second. Thank you. There we go. Neither a relative maximum or minimum at X equals 6, good, because, now here's your source you're citing. F prime does not change sign there. I think that might have only been worth 1. Let's see. You all should have got it. Yeah, 1 point. You either got it or you didn't. You get it? Okay, I've filled those sentences into you, so that should have been fun. Inquire.
We just neither, but
I like to believe that they would give it to you because it's implied in the problem. But just to be safe, neither a relative maximum or minimum. Because if you just say neither, like neither an elephant or a koala, you know what I mean? Like, what do they know? You know what I mean? So like you want to mention what the things are, but it's implied in the problem. So I like to think that if you just said neither, they'd give it to you. All right, letter B. I'm just going to fit this in right here. On what open intervals, and that does mean parentheses, to clarify, because we were talking about that. Is the graph of f concave down? Again, this is not the graph of f. You have to use this graph to interpret. So what intervals did you say? Concave down. -2 to 0 is correct. Union. Good. That was worth a point. If you got those intervals, give yourself 1. Then the reason is worth a point. So because f prime is decreasing there, that was worth a point. You should be at 3 points so far.
If I really try to it down,
Yeah.
like this, that would be.
Perfect. Yep. All right. This is your L'Hopital's rule. I heard you guys talking about this. It's worth 3. Here are the 3 things that you need to do. The first one, and it's a little bit of writing, okay? You have to do the limit as x goes to 2 of the numerator, and then you have to do limit as x goes to 2 of the denominator separately. If you didn't do that, write it now. You have to do them separately. Hold it together. Now we're going to plug in 2 to each of those. So this first one, f of 2, they either have to have just flat out handed it to you or given you a way to find it. What is f of 2? Go back somewhere. It has to be somewhere. 1, do you see that right there? So that's 6 times 1 minus 3 times 2. Again, we're plugging in 2 for x. So what does that equal? This one, you're going to plug in 2. So that's going to be 4 minus 10 plus 6, which is, that's worth a point. If you did both of those separately and showed that they were both 0, you got a point. All right, here's the L'Hopital's rule. And if you're like, I don't want to write this again, okay, then you just won't get the points. You're going to copy this problem literally exactly like it looks and just don't complain about it. Just rewrite it literally exactly like it looks. You have to link these 2 things together. So you write the original problem equals, not plus.
I knew that.
Limit as x goes to 2, and then the derivatives. That's what L'Hopital's rule is. So you're showing that you understand what it is, okay? So it would be 6 and then what? F prime of x minus 3, good, over 2x minus 5. That's worth a point. So again, doing these both separately and showing they're 0, that's worth 1. Linking these together is worth the second point. And then actually getting your answer is the third point. Now we're going to plug in 2. 6 times f prime of 2. They have to have either flat out told it to you or given you a way to find it. Well, what do we have the graph of?
F prime.
F prime. So what is f prime of 2? 0. Good job. Perfect. Minus 3 over, and then here you're just going to plug in 2. You do not need to simplify that down, so please don't. That's worth a third point. So did some of you get this one and that one? Like, did you get 2 out of the 3? Because it sounded like you guys linked these. Did you link those together?
Yeah.
Did you get an answer?
Yes.
Okay, you got 2 out of the 3 then. Good job.
Well, actually, yeah.
Where did you forget a limit?
Then like write the limit in front.
Of this one?
Yeah.
Dahmer, did you get the last one though? You would get the answer point. I think you would. Here, hold on. Before I say that, let me go. Sometimes if you don't get the second point, you're not eligible for the third one. Here, let's see. Let's see how evil they are. Okay, there's just that one. And then, well, you know what? It says applying L'Hopital's rule. So if at least one of your derivatives was correct, they would give it to you. Third point is earned for correct answer with supporting work. I would have given it to you. If you had, well, did you show them both equal 0 separately?
No.
If it works like this, if you did these separately equal 0, that's a point. If you linked these together, that's a point, and then the answer was worth a point. That's how the 3.
The link except without the limit.
Okay, then you would not get that one. So you would get the answer point though.
Right out for like 6 times 1 minus 3 times 2. Or can you just be like, yeah.
Good. You can actually skip that and just write 0. But I'm doing the problem in front of everyone, so trying to explain. And I did see one, I don't remember when it was, must have been a while ago, where it actually didn't come out to 0. It came out to like something, and then you didn't have to do L'Hopital's rule. So you do always want to check. Did you guys all hear that? I saw one once where it wasn't L'Hopital's rule. You just plugged in the number and it gave you an answer and you were done and you move on to the next one. So be careful. It's not always 0. All right, last one. I heard you guys saying this absolute means what test? Candidates. Okay. I did look through the scoring guideline before this. Who are your candidates? Critical points and endpoints, and critical points come from derivative equals 0. I went through the scoring guideline and I actually don't agree with this. I don't agree with something College Board did. Surprise, surprise. If you don't write that on your paper, you don't get that point. They won't give it to you. I know. I'm sorry. I'm just telling you so that when you go in and take your test, will you remember it now? Like put it? I'll be honest, when I did this problem, I didn't write that. I just mentally did it, but I didn't write it on the paper. I would have lost that point too. Just write every single thing you can think of because oftentimes it's worth something. All right, so who are the critical points and endpoints that we're looking at here? What is it? -2, what else? -1, 2, 6, 8. Cool. Now this part's hard. You have to use this initial condition. You're starting at 1, and then your integration does not begin at 0. It begins at 2. So for all of these, it's 1 plus integral from 2 to wherever. Go ahead and write them out. Oops, that should be a 1. It's 1 plus integral 2 to whatever number it is that you're trying to get to. I would just write them all out. It's not that many of them, and then you won't mess them up. Now what we're going to do is go back up to that graph at the beginning and slice it apart and get all of our areas, and then we'll be able to answer all of these. Technically, every single one of these should say f prime of x dx, but they won't take off if you don't put that. This is kind of just a note to self at this point. As long as your answer is right, they're going to give it to you. All right, so let's go back up here and slice this apart. Did you find your areas? Did anybody do those? Areas of your shapes? What is this little triangle worth?
Oh, we're not making a big one?
1? That's 1? This right here? I'm confused. Are you okay? All right, and then this one in here would be -1. And then this one, -2. This one is +2. Now here's where this gets weird. Because you need the areas of these weird things in here. Did anyone have a good idea? It sounded like you guys made it through it. Yeah, the rectangle minus the semicircle. Okay, so how much was the rectangle? 8 minus the semicircle, which is 1/2 pi r squared. So what is the radius? 2. So that would be 8 minus 2 pi. And then you have to split that in half for each one of these. So what is this little amount right here worth? If you split this in half, divide it by 2. Good. 4 minus pi is this one, and 4 minus pi is that one. That sounds like you guys hung in there. Good job. I think that was hard. Now, I don't want to keep moving my paper up and down to make you seasick. Did you write all that down? So if I move this down here, I don't have to keep on going like this? Okay. So we want to do 1 plus our integral from 2 to -2. Now you're going backwards. So if you go from 2 to -2, what's that going to give you? I guess I will move my paper down. Hold on, look it. We're going to go from 2 backwards to -2. So it would be +2 plus 1 minus 1. So just +2 because these ones are going to cancel out. And then 1 plus 2, children, is 3. Okay, next one. It's going to be 1 plus, now you want to go from 2 to -1. So going backwards. So good. And then 1 plus 3 is 4. Good job. This one's the easiest one because what is your integral 2 to 2?
0.
Yeah, 0. So that's just 1. That was the initial condition. 2, 1. All right, this is going to be 1 plus integral 2 to 6. So if you go from 2 to 6, so +2 and then +4 minus pi. Can we do an approximately? Now, if this ends up being the answer, don't use the thing that you approximated. Just pretend pi is 3. Pretend it's about 3. What is that going to be then? Like approximately. It's minus pi. You just went the wrong way. All right, and then this one's going to be 1 plus, now you're going to go from 2 all the way to the end. So plus 2 plus 8 minus 2 pi. So again, pretend pi is about 3. This would be minus 6 here. So approximately 5. I forgot what they asked for. Minimum. So we're going to say absolute minimum is what? Go ahead. Okay. What's the smallest result that we got? 1 at x equals 2. I combed through this scoring guideline earlier. That's how I found this out, and I was really frustrated by it. But this was worth a point, and it says, here, I'll show you. You don't get it unless you write, look. You look at how evil this is, because I was so mad when I saw this. It says, scoring notes. To earn the first point, a response must state f prime equals 0 or equivalent. Just listing the zeros is not sufficient. Practically through my computer. I know, right? You should retroactively earn. I feel like if you had all of these listed out in the table, you knew to set f prime equal to 0. They're mean. Anyway, the point for that, it was a point for doing this whole table and then a point for the answer. So it was worth 3. Go ahead.
Well, I mean, I guess I see why it would be wrong. Like, so, but none of that, just look at the graph and say, okay, all this integral is only.
I'm gonna pause my recording here.